Okay, then we were discussing about the vitamins, and under that vitamin is a water insoluble vitamin. Its source, its synthesis, and its biological importance we discussed in our last class. And today we will discuss about vitamin B1. Okay, so vitamin B1 is also called as thiamine. Okay, vitamin B1 is also called as thiamine, and it is a water soluble. So if we are looking into the source, it is present in eggs, peas, rice. Again, this is repeating. Yes, it's a branch and beans, nuts. Okay, it's also present in yeast extracts and some other vegetables. If we are looking into the deficiency effects, loss of appetite, weakness, fatigue, insomnia, and irritability. Okay, extreme deficiency may result in beriberi. This is one disease, and injury to the brain. So this is about the deficiency of vitamin B1. So, if we are looking into the structure, this will be the structure. I think you are aware that this six-membered ring with the two nitrogen at 1 and 3 position is called pyrimidine, and a five-membered ring with the sulfur and nitrogen at 1 and 3 position is called thiazole. So that means pyrimidine and thiazole are joined through a methylene carbon atom. So the complete compound is called vitamin B1, and it's also called as thiamine. Okay. So with this, I will go to the next slide. I will go to next slide. Next slide, I'm explaining about the synthesis of vitamin B1 or thiamine. Okay. So this synthesis is started with two reactant. This is one, and this will be the one more. So what is the name of this compound? You know that this group C2H5 is called ester group. Okay, and CHO is called C, means one carbon atom. So, and how this is joined, O E2 C2H5 means ethoxy group, COH. Okay, HCOOC2Hy is called ethyl formate. I think you know that formic acid. The formic acid is treated with ethanol to get this compound. Okay, name of this compound is ethyl formate. So it will act as a sodium formaldehyde. So that means you know that this is an ester group, CO2 C2Hy. This is also a ester group, and this is one carbon atom, this is another carbon atom. So since it is a ester functional group or carboxylic acid functional group, we have to give priority to this carbon. This is 1 2 3. So that means 3 ethoxy, this group is ethoxy, 3 ethoxy ethyl pro, propionate is the name of this compound. So then what will happen? You know that this is carbon is attached to oxygen. This carbon is attached to electron deficient carbonyl carbon. So since this carbon is attached to electron deficient carbon, this carbon is electron deficient, and this proton is the proton attached to this carbon is electron deficient. So in presence of base, here the base is sodium that can obstruct a proton from anion here. So this anion attacks this carbon, and OET will go out. So OET will go out as a sodium ethoxide. What it means? It means that there will be a new bond formation between this carbon and this carbon. So that's what I have written here. So now there will be a this obtained intermediate. It is treated with amidine. Okay, amidine means NHC double bond NH functional group. These are called amidines. Okay, NH2 C double bond NH. functional group containing ones are called uh, amidines. Are called amidines. Okay, so that means uh, uh, okay. So this functional group NH2 C double bond NH2. This functional group containing compounds are called amidine functional group. So amidine, when it is treated with the now you know that this is a carbonyl, this is also a carbonyl, and 1, 2, 3, 1, 3 dicarbonyl compound. So hamidine, when it is treated with 1, 3 dicarbonyl compound, we will get what is the name of this compound? Pyrimidine. Pyrimidine substituted product. How this is obtained? You know that there will be a new bond formation between this carbon and this carbon. Okay, so that means uh, uh, ethanol will be the living group. When this is attacking this carbonyl group, OET picks up this proton going out as a ethanol. Similarly, there will be a new bond formation between this nitrogen and this carbon. Okay, and this aldehyde will get converted into alcohol. Later on, removal of one proton and OH. Okay, it will go out as a alcohol. So overall, what you need to remember here, there will be a new bond formation between this nitrogen and this carbon, this nitrogen and this carbon. So that is how this pyrimidine is obtained. So once the pyrimidine is obtained from here to here, so here the in the first step, it's a phosphorus oxychloride, phosphorus oxy trichloride or phosphorus oxychloride, both are same. So what is the role of phosphorus oxychloride? Its role is to convert an hydroxy. Its role is phosphorus oxychloride role is to convert a hydroxy group into chloro. Okay, so that means phosphorus oxychloride takes up this OH and gives Cl over here. That means phosphorus oxychloride acts as a chlorinating agent. It converts hydroxy group into chlorine. Once the chlorine is obtained, that chlorine, when it is treated with ammonia, ammonia replaces the chlorine with NH2 group. So that is the reason NH2 is obtained. And the first step is chlorination. Second step is a nucleophilic substitution reaction, replacement of chlorine with NH2. So that is how NH2 is obtained. So once NH2 is obtained, so here the reactant HBr. HBr is known for the cleavage of ether. You know that this is an ether. CH2O C2H5. It's an ether. What it will do? The lone pair present on this oxygen reacts with this carbon. Then afterwards, what will happen? Uh, there will be a cleavage here, and there will be a formation of Br. So that means when the lone pair present on this oxygen picks up proton, so there will be a breakage of this bond between the CH2 and O. Then CH2 attains a positive charge. That positive charge will form a bond with the Br minus. So that is how bromide is obtained. So once there is a bromide formation, so this was treated with a compound called thiazole. This is a uh, thiazolamide, thiazole derivative. So this is a thiazole means you know that the lone pair present on the nitrogen, it will form a bond with this carbon or more particularly this group is benzylic carbon. Okay, this is the benzene, no, means pyrimidine. Pyrimidine one, of course it will have a aromatic property, and this carbon is a benzylic carbon. This carbon attacks the lone pair present on the nitrogen, and Br will go out. Go out means how it will go, you know that valency of nitrogen is 3. So when the lone pair are used up in the bond formation, the Br minus will present as a counter anion. So this is the bromide salt of vitamin B1. So this bromide salt can be converted into chloride salt just by treating with the aluminum, silver chloride. Okay, silver chloride. So that means here itself the product is formed, but bromide is more hygroscopic compared to the chloride. So that is the reason bromide salt is converted into chloride salt just by treating with the silver halide. So silver bromide will be the living group and Cl will sit over here. So that is how vitamin B1 is obtained. So just I will repeat how the synthesis was takes place. So it is with two molecule. One is 3-ethoxy ethyl propionate that was treated with ethyl formate in presence of sodium gives a 1,3-dicarbonyl compound. This 1,3-dicarbonyl compounds and reaction with amidine gives pyrimidine containing hydroxy group. So this hydroxy is halogenated with phosphorus oxychloride. Then hydroxy is replaced with chlorine. That chlorine is replaced with amino. Okay, that is how amino is obtained. And then when this is treated with HBr, there will be a cleavage of ether group forming an halide. So that halide is treated with thiazole derivative, and a bromide salt is obtained. That bromide salt is converted into chloride salt when it is treated with silver halide. So this is about the synthesis of vitamin B1. Give the synthesis of vitamin B1. So then you should know the biological importance. So with this, I go to the next slide. So next slide is about the biological importance. What is the biological importance of vitamin B1 or thiamine? Okay. So this is the biological importance. And you know that what is that? I think you are aware about the enzyme coenzyme, isn't it? So coenzyme, enzyme. Okay. So here you know that this part up to this side oxygen part is a vitamin, but when this vitamin in a living system, it will occur as a thiamine pyrophosphate. That means vitamin, when it is reacting with the two molecule of ATP, it will give you a thiamine pyrophosphate. Thiamine pyrophosphate is a coenzyme required by the enzymes that catalyzes the transfer of two carbon unit to the substrate. Okay, so is the biological importance. What it means? So vitamin B1 is the precursor for the coenzyme called thymine pyrophosphate. Thymine pyrophosphate is a coenzyme is required by the enzyme that catalyzes the transfer of two carbon unit to the substrate. Okay, so that is only the biological importance of thymine. So this is the reaction, and this will be the coenzyme. Okay, so you know that. So what is happening here? What is the name of this compound? This is the pyruvate. So how the pyruvate is obtained? Pyruvate is the end product of carbohydrate cycle. So that means the end product obtained from the carbohydrate cycle. So in presence of pyruvate decarboxylase. Pyruvate decarboxylase is an enzyme. That enzyme catalyzes with the help of coenzyme. The coenzyme is TPP. TPP means thymine pyrophosphate. Thymine pyrophosphate is a coenzyme. For this, vitamin A is the precursor. Okay, so this much information is enough for the biological importance of vitamin B1. I think you will also learn more about. So here, just I am giving the reaction. Okay. So reaction saying that a pyruvate is converted into acetaldehyde. So one more question also can be framed based on this biological importance. What is the fate of pyruvate when it is treated with a enzyme called pyruvate decarboxylase and TPP. Okay, just they will give up to this pyruvate. They will give pyruvate decarboxylase. TPP they will give. They will ask you to predict the product, And also they will ask you to write, okay, for you mechanism is not required. So for the seniors, mechanism is required, right? So how do you get, how do you convert pyruvate into acetaldehyde? So for that question also, this is the answer. Okay. So overall, you should, uh, I think several times they asked about the what is the biological importance of thiamine or vitamin B1. So that time you should be able to write this explanation. Okay, the explanation may be thiamine pyrophosphate is a coenzyme is required by the enzyme called pyruvate decarboxylase. This converts a this transfers a two carbon unit to the substrate. So what is happening here? Decarboxylation is going out. And what is the two carbon atom? CH3CO. CH3CO is transferred to the proton. So that is how acetaldehyde is obtained. Okay. This is about the biological importance. Now tell me, is there any doubt in the synthesis between B1 and its biological importance? If there is no doubt, means I will go for a next uh, vitamin. It's called vitamin B3. No doubt, no? Any
Sir,
doubt?
sir, in previous slide, please
Yes.
explain bromination, sir.
Which one? Synthesis
Sir,
or importance?
synthesis. Synthesis.
Synthesis. So, okay.
Bromination part, sir.
Look here. Here, this is you can write down the name also. So this is an ester. This is a carboxylic ester. CO2 means it's an COO C2H5. C2H5 means ethyl group. So this carbon is 1. This is 2. This is 3. So that means 3 ethoxy. 3 position ethoxy propane. Okay. Since it is contain ester, propanoic ethyl ester. Otherwise, what we can say that ethyl uh, 3-ethoxy ethyl 3-ethoxy propanate. Okay, ATE, it should end with ATE. ATE indicates that ester. Ethyl indicates that it's a ethyl ester. Third position ethoxy group is a substituent. So this is the name. And what is the name of this compound? You can also rewrite this. HCO C2Hy. HCO OC2Hy. Then it's called ethyl formate. Ethyl formate is acts as a source of formaldehyde group. And what happens when these two are treated with a base? The base may be sodium in alcohol. So sodium obstruct a proton. The proton present in on this carbon. Why proton is obstructed on this carbon? Because this carbon is attached to electron deficient carbon. That is the reason it obstruct a proton, forming an anion. Once there is a formation of anion, that anion attack this carbon, and this will go out as a sodium ethoxide. There will be a new bond formation between this carbon and this CHO. The obtained one is called 1,3-dicarbonyl compound. How it is 1,3-dicarbonyl? This is 1, 2, 3. 1,3-dicarbonyl compound. This 1,3-dicarbonyl compound react with amidine. How it will react? There will be a new bond formation between this nitrogen and this carbon. So here this ethoxy group, okay, C2H5O will go out as a living group. So there will be a new bond formation between this nitrogen and this carbon. So what I mean to say that okay, and similarly there will be a new bond formation between this nitrogen and this carbon. So once there is a bond formation between this nitrogen and this carbon, this C double bond O is get converted into COH and 1H from here. Okay, so removal of water. 1H from here, OH here will go out as a water. So the obtained one is called pyrimidine. So the obtained pyrimidine hydroxy group is there. No, this hydroxy group is subjected to uh, what is called halogenation. That means halogenation, you know, that conversion of alcohol into halide. So here the Cl, okay, is there. No, OH is replaced with Cl. The obtained chloro compound is treated with ammonia. So then what will happen? Ammonia replaces the chlorine, forming amino group. Then afterwards what will happen? When it is treated with HBr. HBr is a known reagent for the cleavage of ethers. HBr cleaves the ether. How it will cleave? The lone pair present on the oxygen react with the proton, forming a OH bond. Once there is a formation of OH bond, this bond weaks. So when there is a this bond weaks means this bonded pair move towards oxygen. That time Br minus will attack this bromide. So this bromide aryl alkyl bromide attacked by lone pair present on the nitrogen. It is only a salt formation. Okay, this is only a salt formation. The
Sir,
obtained salt is yes.
sir, NH2HBr is
Go
there,
ahead.
no, sir? On top of the
In
compound. NH2HBr.
this one. Yes.
NH2. How do you
It's a
connect it?
salt. It's a salt. How it will form means NH2 is a base that will react with the one more equivalent of HBr. So that is the reason NH2HBr is formed.
What kind of bond is there, sir, in between them?
It's an ionic bond. So NH3 plus
Okay,
Br minus. NH3 plus Br minus. It's a salt.
okay, sir.
Right. So similarly, this is also a salt. This is also a salt. It's an ionic bond. So of course here also I can write NH3 plus Br minus, that I can write. Uh, one can write this way also. Both the writing both the way is correct only. So here the bromide salt is replaced with the chloride salt when it is treated with silver halide. So this is about the synthesis. Okay, no, I think is it okay synthesis?
Okay, sir.
Right. So with this, I will. This is the biological importance. Maybe here you can write only sentence. The sentence may be thymine pyrophosphate. Uh, for this, thymine pyrophosphate is a coenzyme. For this, the precursor is vitamin B1. Thymine pyrophosphate is the coenzyme. It is required by the enzymes that catalyzes the transfer of two carbon unit. So you can observe that this is CO2, it will go out as a decarboxylation, but these two carbon unit is transferred to proton. That is how a acetaldehyde is obtained. So that means thymine pyrophosphate is required by the enzyme that catalyzes the two carbon unit to the substrate. Thereby, it converts pyruvate into acetaldehyde. How do, maybe sometimes they will give you this reaction. They will ask you to explain. So that time you have to tell all these things. So with this, I will go for a next vitamin, and the next vitamin is called B2. So B2, vitamin B2 is also called as riboflavin. Okay, why ribo? So look here, this is a ribose sugar. Okay, this group is called ribose sugar. That is the reason it is ribo. And this group, okay, is called flavin group. So that is the reason it's a riboflavin. Then what are the source for vitamin B2? Of liver is the one source of vitamin B2. Milk is another source of vitamin. Kidneys, okay, beef, wheat germ, okay, rice polishings, okay, rice polishings also a source of vitamin B2, etc. Then what is the deficiency effect? Inflammation of the skin. Okay, inflammation of the skin is the indicates that it's a deficiency of vitamin B2 or riboflavin. So this is the structure. You need to remember that. You know that. I think this complete group is called flavin group, and this group is called ribo group. That is the reason it's called riboflavin. So with this, I will go to the synthesis. How one can synthesize riboflavin. And I think I explained about why we should go for a synthesis, because naturally occurring compounds, suppose if you want to prepare a 10 gram or 100 gram of riboflavin by taking liver or milk or kidney or beef or egg, whatever it is, so it require more quantity. So that means we supposed to consume or use more quantity of the valuable food items. So that is the reason one should go for a synthetic method to synthesize or prepare vitamins. Okay, so just to meet the market demand. Okay, in market there is demand for vitamins. Even nowadays, during this pandemic also, people are taking Ginkgo white. Ginkgo white is nothing but a vitamins only, B complex tablets. Okay, so overall, to meet the market demand, one should go for a synthesis. So then here a synthesis or preparation of vitamin B2 or riboflavin. So this will be the what is called one of the key intermediate or reactant or raw material. Sometimes they will ask you, how do you how do you get riboflavin starting with this compound? They will give you this, but they will ask you to convert this into a riboflavin. Okay, so then what will happen? What you can observe here, this is a NH2, and this NH2 is forming a bond with CO2, C2H5. So NHCO2H is called carbamic acid, and this is a ester carbamate. Okay, this up is a carbamate, ethyl carbamate. So that means ethyl carbamate is attached to this group. Okay, then what will happen here? What it means? It means that NH, one of the NH is protected, another NH is free. That NH react with ribose. You know that ribose. What is ribose? Ribose is nothing but a CH2OH, CHOH 3 times CHO. Okay, so it's a ribose. Ribose means 5 carbon containing sugar, more sugar. Okay, aldo pentoses. So what is there here? Aldose is there. Aldose means CHO is there. That CHO react with NH2. I think it is just a removal of water moiety. So removal of water. So H2 from here, O from the ribose going out, forming a skip base. Okay, this is called a skip base. Then what will happen? Of course, skip base. So then what will happen? This skip base is treated with hydrogenation in presence of catalyst. Well, I think you know that catalytic hydrogenation. So catalytic hydrogenation means addition of hydrogen in presence of catalyst. So what it means? It means that hydrogen is added to this double bond, converted into single bond, NCH2 NH. Okay, converting double bond into single bond. So it is, that is only catalytic hydrogenation. H2 is added, one H here, one H here. So that's what I have written here. So then afterwards, what will happen? So hydrolysis. So you know that it's a carbamate, ethyl carbamate. What will happen? NHCO, O, C2H5. So the ester is cleaved. Ester is cleaved. What will be the byproduct, ethanol will be the byproduct, and later on the CO2H formed one undergoes decarboxylation on heating, giving rise to removal of carbon dioxide. Removal of carbon dioxide. So once there is a removal of carbon dioxide, what you will get? You will get a free amine. So you need to remember that when it is treated with NaOH, there will be a cleavage. This particular cleavage. Cleavage means ester is converted into acid. Ester is converted into acid means there should be a living group called ethanol. And the obtained acid on heating undergoes decarboxylation, removal of carbon dioxide, and converting into a free amine. Okay. So the obtained free amine is treated with alexan. Okay, this is one key intermediate. You just remember this. Some in laboratory, some people used to say that alexan is the one chemical. It is present in wheat powder, and that is causing cancer. That's what some people prediction. This haloxan, when it is treated with diamino compound in presence of boric acid, it will give you riboflavin. Okay, so you know that how it will react. Okay, so there will be a reaction between this NH and this OH. There will be a reaction between this O and this NH2. What it means? It means that removal of water, more particularly two molecule of water, HOH, one water, OH2, another water. What it means? It means that you can write this part will be this much. Then there will be N will be forming a double bond with this, and N is forming a new bond with this carbon. So that is how riboflavin is obtained. So with this, I will go to the biological importance of vitamin B2 or riboflavin. So I think you are, of course, what I am writing here, you can observe that this is a double bond, single bond, double bond, N. So this particular portion, okay, right. So this particular portion, okay, is important. This is only the active site. So what it will do, uh, this bond pair can come over here. This bond pair can picks up a proton. What it means? It means that it can undergo oxidation reduction. So what it means? It can accept a two protons and convert into a reduced form, and it can give a two protons and convert into a oxidized form. What it means? It means that it is involved in a biological oxidation system, oxidation reduction system. Okay, how means because of the presence of this bond nature, N double bond CH double bond N. So this can accept two electron. Once after accepting two electron, it's converted into reduced form. This reduced form can give two hyd- uh, hydrogen to the substrate. So what it means? It means that this can accept a hydrogen or proton from the substrate. What it means? It means that it can act as a uh, oxidizing agent or reducing agent.
Oxidizing agent.
In tissues, riboflavin occurs chiefly in the form of flavin mononucleotide. So flavin mononucleotide means FMN and flavin dinucleotide FAD. So FMN and FAD function as a coenzyme for the enzymes called flavoproteins. Okay. So then D and L amino acid oxidase is one flavoprotein. Glycine oxidase is another flavoprotein. And then xanthine oxidase is another flavoprotein. Glucose oxidase is another flavoprotein. The flavoproteins function as a important enzymes in tissue respiration. They catalyze the direct oxidation of substrate by oxygen with FAD-FMN undergoing simultaneous oxidation reduction. So this is about the biological importance of uh, vitamin B2. So what it means, more particularly what I can say that this riboflavin occurs as a coenzyme. The enzymes catalyzes the enzymes involved in the oxidation reduction system in living system. For example, DL amino acid oxidase, glycine oxidase, xanthine oxidase, glucose oxidase. I think maybe you will learn more details when you are in the third semester. So at this moment, you just maybe this information is enough as the biological importance of vitamin B2. So more particularly what I can say that, so whatever the oxidation reduction happening in the living system, it's because of FMN. FMN means flavomononucleotide. So what is the difference between FMN and FAD? Flavin adenine dinucleotide is FAD. So FMN is okay. I think you know that this is riboflavin. No, suppose this hydroxy group is phosphorylated, then we can say that FMN. Suppose this hydroxy group is phosphorylated, more particularly if this hydroxy group is attached to the adenine dinucleotide. So that time it's called FAD. So overall, what I mean to say that riboflavin is in it will exist as a coenzyme in the form of FMN and FAD. FMN, FAD are the coenzymes, so that are required by the enzymes that are involved in a oxidation reductions of the substrate. Is it okay? Is there any doubt in the biological importance as well as the synthesis of vitamin B2? Any doubt?
No, sir.
No, sir.
No. Okay. Fine. Maybe what I will do, uh, maybe I will stop at this stage. Maybe I will continue in my next class. Otherwise, I can go for one more vitamin. Vitamin C, I can go. Anyway, next class I will take up vitamin C and one more pyridoxine. Okay, maybe I will stop at this stage. Maybe what I will do now, I will stop sharing. Maybe you can log out.
Thank you, sir.
Okay, no problem.